This is part 2 of algebraic structure. If you haven't seen part 1, watch that first and then come back to this. Monoids and groups. Let us take a set of objects and a rule, called a binary operation, which allows us to combine any two elements of this set. Addition is an example from math, or ANDing in some computer language. The set must be closed under the operation. That means that when two elements are combined, the result must also be in the set. For example, the set containing even numbers will always give us an even number when two elements are added together. But if we restrict ourselves to odd numbers, their sum is not an odd number, and so we know right off the bat that the set of odd numbers in addition cannot constitute a group. Some books will consider closure in the definition of binary operation, and others add it as one of the requirements for a group along with the ones that follow below. Set in the operation is called a group if the binary operation satisfies the following criteria. Operation is associative, which means it doesn't matter how you group the elements you are operating on. For example, in our set of remainders, 1 plus 3 plus 4 equals 1 plus 3 plus 4. There is an identity element, meaning one of the elements combined with the others in the set doesn't change them in the least. For example, the 0 in addition, or the 1 in multiplication. Every element has an inverse with respect to that operation. If you combine an element and its inverse, you get the identity of that operation back. A set of natural numbers n, with the operation of addition, is not even a group, since there is no inverse for 5, for example. In other words, there is no natural number which added to 5 will give us 0. About the set of integers, is it a group? By itself, this question is nonsensical. Why? I have not mentioned under what operation. A set of integers with addition. Addition is associative. The 0 does not change any number when added to it, and for every number n we can add minus n and get 0. So it's a group, all right. In fact, it is a special kind of group. We can perform the operation on the two elements in any order, e.g. a plus b equals b plus a. Then the group is called commutative, or abelian in honor of Abel. Not every operation is commutative. For example, 3 minus 2 is certainly not the same as 2 minus 3. Our set of integers under addition is then an abelian group. Follow my page and save this video so you don't miss part 3 of this topic.